Well students, we have some more questions based on Lagrange's mean value theorem. With that, our complete the calculus, differential calculus will conclude. Next question, it's class number 41. Verify mean value theorem. So it may be Lagrange's rows if f of a equal to f of b. If f of a not equal to f of b, then you must apply Lagrange's mean value theorem. So verify mean value theorem for the function f of x equal to x plus 1 divided by x on the interval 1 comma 3. So write solution. Here a from interval, what we can get is that a 1 b 3. So according to that f of a, f of 1 equal to 1 plus 1 by 1, but 1 by 1 is 1, total is 2. Same time f of b means f of 3 in the function now. Put x equal to 3 plus 1 divided by 3, LCM 3 into 3, 9 plus 1 is 10 divided by 3. And what we can observe is that f of a very clearly not equal to f of b. Clearly. Means no doubtly, clearly f of 1 not equal to f of 3. That means we are supposed to apply Lagrange's mean value theorem but not Rolle's theorem. Let's differentiate 1. So this is function 1. Now differentiating 1 with respect to x. Differentiation of fx becomes f dash x. Right hand side, differentiation of x 1, whereas differentiation of 1 by x is minus 1 by x square. Also which implies that very easily f dash of c equal to 1 minus 1 divided by c square. F dash x does not exist only when x equal to 0. But no question of x equal to 0 because interval do not contain 0. Since x not equal to 0, therefore f dash of x exists. F dash of x exists means fx is differentiable. Therefore fx is differentiable. Differentiable on open interval 1 comma 3. By standard theorem, what we have is that every differentiable function is always continuous. Therefore, f of x is continuous on closed interval 1 comma 3. As all the conditions of Lagrange's theorem are satisfied, now we implement Lagrange's theorem. Next write by LMPT we have by Lagrange's mean value theorem we have f dash of c equal to f of 3 minus f of 1 divided by 3 minus 1. F dash of c is 1 minus 1 by c square. F of 3 value is 10 divided by 3 minus f of 1 value is 2 divided by 3 minus 1 is 2. Simplify 1 minus 1 by c square equal to, in the numerator LCM 3 into 2 6, 10 minus 6 is 4 divided by 3 into 2 become 6. So 2 2s are 2 3s are, that is equal to 2 by 3. We shall solve for C. We shall exchange the terms to either side, which implies that 1 by C square equal to 1 minus 2 by 3. Further, in the right hand side, LCM is 3. 3 into 1, 3. 3 minus 2 is 1. Hence, 1 by C square equal to 1 by 3. 1 by C square equal to 1 by 3. Which implies C square equal to 3 on cross multiplication. Hence, C equal to actually plus or minus, but interval do not containing of negative real values, so we shall take only plus square root. C equal to square root of 3. Roughly square root of 3 value is 1.73 to something. So 1.73 to more than 1, less than 3. So obviously this value belongs to the interval for which Lagrange's mean value theorem satisfies. Here x equal to C equal to root 3 belongs to open interval 1 comma 3. Therefore, LMVT long form is that Lagrange's mean value theorem verifies this. Verifies this for x equal to root 3. Next problem. Verify mean value theorem for the function. Verify mean value theorem for the function. Verify mean value theorem for the function f of x equal to x cube minus 5x square minus 3x on the interval a comma b, on the interval a comma b where a equal to 1, where a equal to 1 and b equal to 3. As well as on the interval 1 comma 3. Solution as given in the question here: a 1, b 3, and also f of x as defined as x cube minus 5x square minus 3x. Let's calculate f of a, f of b values. F of a means f of 1, 1 cube, 1, 5 into 1, 5, minus 3 into 1, total minus 7. At the same time, f of 3 equal to, that is 3 cube, minus 5 into 3 square, minus 3 into 3. 3 cube, 27, 3 square, 9, into 5, 45, 3 into 3, 9. 27 minus 54 it is. So 27 minus 54 is minus 27. Observe, f of 1 minus 7, f of 3 minus 27, they are not equal. Hence we need to apply Lagrange's mean value theorem. Clearly, f of 1 not equal to f of 3. Hence we need to apply Lagrange's mean value theorem because f of a not equal to f of b is satisfied. Now we shall get differentiation of function 1. Next step, differentiating one with respect to x. Differentiation of fx is f dash x. Right hand side by sub rule. Differentiation of x cube 3x square minus differentiation of x square 2x. 2 into 5x will become 10x. Then differentiation of minus 3x is minus 3. And also we shall estimate at the same time f dash of c will become 3c square minus 10c minus 3. Because of f dash of x do not contain any x in denominator, no question of 0 by 0 form, means very clearly f dash x exists. But that word clearly f dash of x exists. Clearly f dash x exists. Therefore, fx is differentiable. On the open interval 1, 3. And every differentiable function is always continuous. Therefore, fx is continuous on the closed interval 1, 3. Let's apply Lagrange's mean value theorem by NM VT we have. That means by Lagrange's mean value theorem we have f dash of c equal to f of 3 minus f of 1 divided by 3 minus 1. F dash of c is given by 3c square minus 10c minus 3. F of 3 value is minus 27. F of 1 value is minus 7 divided by 3 minus 1 is 2. Let's simplify. Three c square minus 10c minus 3 equal to minus 27 minus of minus plus 7 divided by 2. 3c square minus 10c minus 3 equal to minus 27 plus 7 minus 20 by 2 is minus 10. Minus 10 become here plus 10. Total becomes 7. 3c square minus 10c plus 7 equal to 0. Which is a normal quadratic equation in C. Multiplying 21, adding minus 10. And very clearly those numbers are minus 3 into minus 7 will be 21. Whereas minus 3 minus 7 will be minus 10. Select factors. On factorization we get 3c square minus 3c minus 7c plus 7 equal to 0. In the first two terms 3c common, 3c into bracket c minus 1. Next two terms minus 1 common, in the bracket c minus 7 common. In fact, left in the bracket is c minus 1 equal to 0. Here minus 7 common, here 3c will be the common. Again common c minus 1, that gives c minus 1 into 3c minus 7 equal to 0. or either c minus 1 equal to 0 or 3c minus 7 equal to 0. Which implies c equal to 1, another c equal to 7 by 3. But c equal to 1 does not belong to open interval because it belongs to closed interval. In fact, it is the first member of the interval. Here, x equal to c equal to 1 do not belongs to open interval 1 comma 3. Means for this value of x, LMVT not verifies this. Therefore, LMVT not verifies this. For x equal to 1 means at point x equal to 1 there is a tangent but not parallel to the chord joining the points 1 and 2. That's the meaning. Whereas also x equal to c equal to 7 by 3, roughly it is 2.3, but belongs to interval, belongs to open interval 1 comma 3, and for this value of x, Lagrange's theorem holds. Therefore, LMVT verifies this. For x equal to 7 by 3. That means at point x equal to 7 by 3, there is a tangent which is parallel to the chord joining the points x equal to 1 and x equal to 3. Like this, any other examples you need to solve yourself. There is no much more problem. First get f of a, f of b. If they become equal, apply Rolle's theorem. If they not become equal, apply Lagrange's mean value theorem. In either cases, you have to find c. C belongs to interval, theorem verifies this. Otherwise, theorem does not verify this. Let's have some discussion about MCQ problems of continuity as well as differentiability. In fact, this will answer the theoretical part of our continuity, differentiability as well as differentiation. This is an winding up of theoretical part of differentiability, continuity and differentiation. Let's have some idea about MCQ problems, means multiple choice question problems. Before we take up those problems, we shall discuss some shortcut methods, standard results, etc. They will be very much useful in saving the time, especially MCQ examination. But these shortcut methods not to be applied in theoretical classes, theoretical examination. If you apply, you may lose the marks. So these upcoming shortcut methods meant only for MCQ examination. Common entrance test examination, maybe JEE, KCET, whichever you adopting. So be careful. These shortcut methods meant only for MCQ examination, not for theory examination. If you apply in theory examination, you may lose the marks in that, no doubt. So we first begin our shortcut method with L hospital rule. All this part is concerned to MCQ questions, multiple choice questions. L hospital rule. You can mark heading as standard results and shortcut methods. Standard results and shortcut methods. Concerned to continuity, limits, differentiation and differentiability. These methods to be applied only for MCQ problems, not in theory problems. Be careful. The L hospital rule says that, see, if f of x, g of x are two functions such that limit of f of x divided by g of x as x tending to a becomes 0 by 0 form, or even it can become infinity by infinity form. So if our limits tends to any one of these indeterminate form, already we know about indeterminate form, the mathematical form whose value cannot be predicted, that is called as an indeterminate form. Among them, basic one 0 by 0 followed by infinity, 0 into infinity, infinity minus infinity, 1 for infinity, infinity for infinity, etc. These are all called as indeterminate forms. Means mathematical forms, no doubt, but their value cannot be decided to no extent. That's why these are called as indeterminate or unpredictable format. Among these, basic one is 0 by 0. So if our limit tending to either 0 by 0 form or infinity by infinity form, now L hospital rule says you can differentiate numerator separately, denominator separately. That is limit f dash x divided by z dash x as x tending a. Provided f dash of a by z dash of a do not become either 0 by 0 form or infinity by infinity form. Means this should not be undertaken by 0 by 0 or infinity by infinity form. If it become again 0 by 0 form, suppose if it become again 0 by 0 or infinity by infinity form, once again we can apply L hospital rule. And L hospital rule, simple meaning is that differentiate numerator, differentiate denominator separately, provided your limit must be either 0 by 0 form or infinity by infinity form. But in other cases, you have to transfer to either 0 by 0 form or infinity by infinity form. Then you need to apply L hospital rule. So keep in mind, L hospital rule applied only for either of these two cases, but not in other indeterminate form case. And once again a reminder, this is concerned only MCQ, not theory. This all discussion concerned to MCQ but not theory. Don't apply in theory problems, you may lose the marks. But you can apply 100% to save the time in MCQ examination. See, if at all limit of f dash x by z dash x once again becomes 0 by 0 form, we can apply once again L hospital rule. Means limit extending to a f double dash x divided by z double dash x. That means you can differentiate second time. Like this, you can continue applying L hospital rule until we get perfect known answer. Means until we get known real answer, still then we can apply L hospital rule. And L hospital rule, simple scheme, simple method is that differentiate numerator, differentiate denominator separately. Keep that in mind. So for example, evaluate limit extending to 0 1 minus cos x divided by x square. If you apply first year PUC methods, you need to apply trigonometrical method. 1 minus cos x is 2 sin square x by 2, and use sin theta by theta formula, etc. Now we can apply L hospital rule. So now given problem is limit extending to 0 1 minus cos x divided by x square. Orally verify. What is x? 0. 0 square? 0. What is x? 0. Cos 0? 1. 1 minus 1? 0. Now it is under the control of 0 by 0 form. But it is an indeterminate form. Means unpredictable form. You have to get into valid form. For that we apply L'Hospital rule. Lewis Hospital rule. And L'Hospital rule says that differentiate numerator separately, differentiate denominator separately. So limit extending to 0. Differentiation of 1 minus cos x is sin x. Because differentiation of 1, 0. Differentiation of cos x minus sin x, minus of minus plus sin x. Divided by differentiation of x square, 2x. Still it becomes 0 by 0 form. Because sin 0, 0 and x 0. You can apply once again L'Hospital rule. Or you can use directly theorem also. What theorem? Limit of sin theta by theta is 1. Choice is yours. You can apply L'Hospital rule, or you can use directly theorem like limit of sin theta by theta 1 from our earlier previous first year standards. So this is 1 by 2 into limit of sin x by x as x tending to 0. But the standard theorem, limit of sin x by x is 1. So it is 1 by 2 into 1, nothing but 1. So we got this problem answer through L'Hospital rule. And L'Hospital rule says that differentiate numerator separately, differentiate denominator separately, provided your limit must be either 0 by 0 form or infinity by infinity form. But in any other cases, L'Hospital rule cannot be applied. Keep in mind, suppose you got 0 into infinity form, you have to convert it into either 0 by 0 form or infinity by infinity form by suitable steps. Then you need to apply L'Hospital rule. So this is very important shortcut method, especially limit containing problems. You try to keep this in memory. But don't apply in theoretical problems, apply only in MCQ problems. We have some standard results or shortcut methods concern the limit concept. Last one, what I explained, Lewis Hospital rule applied only for MCQ problems, not for theoretical problems. So let's some standard results or shortcut methods on limits. First, you can mark short star, limit extend to 0, 1 minus cos mx divided by x square. You remember it, its answer is always m square by 2. Next, limit extend to 0, sin mx divided by x. It is equally same as limit extend to 0, tan mx divided by x. In these two cases, always answer is m. Actually, we have to multiply and divide by m. Here m by mx, sin mx by mx value is 1. 1 into m is m. Next shortcut method, limit extend to 0, 1 minus cos mx divided by 1 minus cos nx. Using earlier one, actually it become m square by 2 divided by n square by 2 after dividing x square to numerator and denominator, but it is actually m square divided by m square. M square by m square. It's a very useful problem to save time. Keep in memory without fail. Next, limit extending to 0. Cos ax minus cos bx divided by cos cx minus cos dx. Its answer is always a square minus b square divided by c square minus d square. Or it may be b square minus a square by d square minus c square. For example, suppose you want to find the limit extending to 0, cos 5x minus cos 2x divided by cos 3x minus cos 4x. One method is that applying the unspecified rule, but still a better method, still more time saving method is that this one, a square. What is a square? 5 square. What is b square? 2 square. What is c square? 3 square. What is d square? 4 square. That is 25 minus 4 divided by 9 minus 16. That is 21 divided by 9 minus 16 is minus 7. 7 ones are 7 threes are minus 3 is the answer. Next point, next shortcut method, limit extending to 0. f1 ax plus or minus f2 bx divided by f3 cx plus or minus f4 dx. Still we can have number of functions, f5, f6, etc. is always equals to a plus or minus b divided by c plus or minus d. This is applied not for all the functions, only when f1, f2, f3, f4 either they are sine function, tan function, sine inverse function or cos inverse function. Tan inverse function. Right where f1, f2, f3, f4, etc. are functions like sine, tan, sine inverse, tan inverse, etc. Only in these exclusive cases this shortcut method will be valid. Means a plus or minus b by c plus or minus d, where a, b, c, d are coefficient of x either in sine function or in tan function or in sine inverse function or in tan inverse function, depending on that problem. And you can observe, for example, suppose you want to find the limit extending to 0, sine 3x plus tan 2x divided by sine 5x minus sine 4x. If this were be the problem in MCQ exam, not in theoretical exam, actually in theory exam you have to divide NR and DR by x, here 3, here 2, here 5, here 4 is the answer. Hence now upcoming answer 3 plus 2 divided by 5 minus 4, that total answer is 5. 3 plus 2 5, 5 minus 4 1, 5 by 1 is 5. And I warn that these shortcut methods valid only for MCQ questions, not elsewhere. Be careful in attempting these shortcut methods in theoretical examination. Next, another important formula we have, limit extending to a fx to the power of gx. It's always defined by e raised to limit extending to a bracket g of x into bracket g of x into bracket f of x minus 1. This method is useful whenever we have function to the power of function, and especially our limit takes to the format 1 to the power of infinity. If our function tending to the indeterminate form like 1 power infinity, this method is very useful. For example, let's see how this formula will be applied in this kind of problems. For example, write limit extending to pi by 2. Limit extending to pi by 2 tan 2x to the power tan x. Tan 2x to the power of tan x. Think that you are evaluating this problem. Verify. When you put here impact. Like this. Evaluate limit extending to pi by 4, make it tan x to the power of tan 2x. Now observe, or we check it. What is tan pi by 4? 1. Here 2 into pi by 4 means pi by 2. And what is tan pi by 2? Infinity. Actually it is tending to 1 to the power infinity form. Now let's apply this form. It is just like limit of fx to the power of gx. What is fx? Tan x. What is gx? Tan 2x. Using that formula. Now it is equal to e power limit extending to pi by 4. gx. What is gx? Tan 2x. Into bracket fx minus 1 means tan x minus 1. Now it actually becomes 0 to infinity form. We got tan pi by 4 1, 1 minus 1 0. Here pi by 2, and what is tan pi by 2? Infinity. It is under 0 into infinity form or infinity into 0 form, but we can't apply L-Hospital rule. So we shall transfer it into either 0 by 0 form or infinity by infinity form. For that case, what we shall do is that e power limit extending to pi by 4. I will write tan 2x as divided by cot 2x. So it is tan x minus 1 divided by cot 2x. Now it's very clearly under 0 by 0 form. Because here we get cot pi by 2. What is cot pi by 2? 0. Here we get 0. It is under 0 by 0 form. Let's apply L-Hospital rule in that case. Using L-Hospital rule. And What does L hospital rule says that differentiate numerator and denominator. That is equal to e power limit extending to pi by 4. Now differentiate numerator and denominator separately. That's what the scheme of L hospital rule says. E power differentiation of tan x secant square x, whereas differentiation of 1 0 left out, divided by differentiation of cot 2x is minus 2 cosec square 2x. But all this is happening in the power of exponent here. Now check over here. When we replace x with pi by 4, it becomes pi by 2. What is cosec pi by 2? 1. That means we will not get 0 by 0 form. Replace x by pi by 4. E power minus 1 by 2 in. Now replacing x by pi by 4, here secant square pi by 4 divided by cosec square pi by 2, because 2 into pi by 4 become pi by 2. So that is e to the power minus 1 by 2 into how much sec pi by 4? Root 2. That means root 2 square divided by how much cosec pi by 2? 1 means 1 square. Root 2 square 2. The total e raised to minus 2 by 2. 2 cancels. Root 2 square 2. 1 square 1. So final answer e to the power of minus 1 or 1 divided by e. You realize we evaluated this problem very easily by this formula. So this formula is very, very crucial. This formula applied whenever you want to evaluate limit of the type, limit x to the power of gx, and its formula is given by limit of gx into bracket fx minus 1, provided the limit must tending to the format 1 power infinite. Still we have concept. We shall meet in the next class. Thank you. Gururaj.